We've already seen in an earlier video that enantiomers are stereoisomers that are non-superimposable mirror images of each other. So let's say we want to draw the enantiomer of this compound on the left. One way to do it would be to reflect this compound in the mirror. And if you look at this carbon skeleton, here we have our carbon skeleton with our OH group coming out at us in space. That's this model on the left. There's our carbon skeleton with our OH coming out at us in space. If we reflect this compound in the mirror, we'll see the enantiomer in the mirror. Our mirror image on the right is non-superimposable upon our model on the left. So let's just draw what we see. We see our carbon skeleton like this. All right, so let's draw that. So there is our carbon skeleton, and our OH group is coming out at us in space. So we could represent that with a wedge. So let's fill in our wedge here, and let's draw our OH. And so this drawing on the right is the enantiomer to the drawing on the left. There's another way to represent the enantiomer on the right, and to do that, let's check out the video. So in the video, I imagine an axis going through this carbon, and then I rotate about this axis to give us another viewpoint of our other enantiomer. So here's a model of our enantiomer, and you can see our carbon skeleton with our OH coming out at us, attached to this carbon, and then a hydrogen going away from us in space. If we imagine rotating about an axis through this carbon, so let's go ahead and do that, we'll see another way to look at the enantiomer. So now we have, for our carbon skeleton, you can see our carbon skeleton looks like this now. And then at this carbon, we have the OH going away from us in space, and the hydrogen's coming out at us. So here we have some pictures from the video to help us with our drawings. We can see that this picture is this compound. If you look at that carbon skeleton, and you can see the OH coming out at us in space. So in the video, we took this compound and we rotated it to give us this image on the right. So these are just two images of the same compound. And this gives us another way to draw our enantiomer. This time our carbon skeleton is going like that. So let me go ahead and draw in our carbon skeleton. And our OH group is going away from us in space. So we have to put in the OH group with a dash like that. So these two drawings represent the same compound, the enantiomer that we were trying to draw. So there are two main ways to draw enantiomers, at least two ways that I like to use. The first way is to reflect the compound in a mirror, and that's what we did first. We took this compound and we reflected it in the mirror, and we drew what we saw, and that gave us this drawing of the enantiomer. We've seen that this drawing on the right is the same thing as this drawing on the left here, and notice the difference between this drawing and our original compound. The carbon skeletons are the same if you look at these two. The only difference is we changed the wedge to a dash. So that's another very convenient way to draw an enantiomer. If you're starting with a wedge, change it to a dash. If you're starting with a dash, change it to a wedge. Now let's draw the enantiomer of this compound. And the first method we'll use is the mirror method. So here's a simplified representation of our compound, so ignoring things like conformations of our ring. At this carbon, our bromine is going down in space, so that's this carbon, so you can see the bromine's going down. And then at this carbon, bromine's going up in space. So that's this carbon with our bromine going up. In the mirror, we can see the mirror image, or the enantiomer. So let's go ahead and draw our enantiomer here. So we draw our cyclohexane ring. And then at this carbon, we have our bromine going down in space. So let's go ahead and put in our bromine going down. And then at this carbon, we have our bromine going up in space. So that's a wedge. So we draw in our bromine here. Let me fill in this wedge. And let's put in the bromine. So this on the right is the enantiomer. And sometimes you don't have model sets or a mirror, but you can draw the mirror image by just using this drawing on the left. You can imagine a mirror right here. And just as you see up here, this bromine is reflected in the mirror. This bromine is reflected in the mirror, right? So these bromines are reflecting each other. And then this carbon is opposite of this carbon. So that's this carbon and this one. And then this carbon is opposite of this one. So this carbon is opposite of that one. So just a few tricks to help you draw the mirror image. So there's another way to represent our enantiomer on the right. And let's go to the video to see the other way. So here we have our two enantiomers, so you can see they're mirror images of each other. If I rotate the enantiomer on the right, you can see it from a different viewpoint. Notice that both chiral centers have been inverted. And just to prove that these are enantiomers of each other, let's try to superimpose one on top of the other. Notice how you can't do it. So these are non-superimposable mirror images of each other. So this picture on the right in the video shows you the relationship between our two enantiomers. So thinking about reflecting the molecule on the left in the mirror, we can see the enantiomer on the right. But we took this molecule on the right, this enantiomer, and I rotated it into this position. So now let's draw the enantiomer from this perspective. We start out with our cyclohexane ring, and you can see at this carbon, our bromine is going down in space, so that must be a dash, so there's my bromine. And then at this carbon, our bromine is coming up in space, coming out at us, so that's a wedge. So let me go ahead and draw in our wedge, and we'll put in our bromine. So this is just another way to represent our enantiomer, so on the right. So this drawing and this drawing are two different ways to represent the same molecule. So this is the enantiomer to the compound on the left. So let's look at our original compound and compare this drawing on the right. Notice at this carbon, your bromine's coming out at you in space, whereas at this carbon, your bromine's going away from you in space. At this carbon, your bromine's going away from you in space, and at this carbon, your bromine's coming out at you in space. So to draw our enantiomer, we just invert all chirality centers. So if you have a wedge, change it to a dash. If you have a dash, change it to a wedge. So this way is often easier. So just make sure to invert all your chiral centers to draw the enantiomer. For bicyclic compounds, it's easiest to use the mirror method. So if our goal is to draw the enantiomer of this compound, we can imagine a mirror right here. And we can use this picture above as a guide. You can see that the hydrogen is reflected in the mirror and the chlorine is reflected in the mirror. So let's go ahead and draw those in. So we draw our hydrogen here and then our bond going down to this carbon and then a chlorine going straight down from here. So notice how this hydrogen is reflected and this chlorine is reflected. Next, let's think about reflecting this carbon. So we need to draw a line in this way right here. So now this carbon is reflected with that one. Let me highlight those carbons. So right here, I'm going to extend this line out a little bit so we can see where the horizontal is approximately like that. So that's this carbon and this carbon, right? So that carbon's reflected in our mirror. Next, let's draw a line up in space relative to that horizontal like that. And that takes us to this carbon, which is reflecting this one in our mirror. Now let's worry about this one. So this should go up in space. So let me draw a horizontal line down here just to help us with our drawing. So approximately horizontal at this point. We know we want to go up in space from this point, so let's do that. So that's this line. So this carbon is reflecting this carbon. Next, let's go ahead and reflect our top carbon here. So let's draw this line over to here. So you can think about this top carbon, right, reflecting that one. So let's draw our lines over here. So from here and then back down to here. So this is more of a drawing exercise, really. And then we're going to go down a little bit. We'll leave that line broken so we can see that one's going behind, and then we'll draw this to the carbon in the back. And then we know we have to draw down from this line to the carbon in the back, and then we can connect those lines. So finally, we've drawn our enantiomer. So on the right is the enantiomer to the compound on the left. And just to prove that this on the right is the enantiomer, let's look at a video where I try to superimpose the mirror image on the original compound. Here we have our two enantiomers, so mirror images of each other that are non-superimposable. Just to prove they're non-superimposable, I'll rotate the enantiomer on the right and try to superimpose it on the one on the left. And you can see that they don't match up. So these are enantiomers.